Hey everyone, Mr. Mitchell here, back for my latest installment of talking about science notes. So today we're going to look at 8.6 patterns in the night sky. This first line here, many civilizations believe that celestial objects were connected with events that occurred on Earth. So historically, many groups, Aboriginal groups or Indigenous groups here in Canada, they quite often associated with patterns in the night sky and events that happen in the night sky with different creation stories, as well. Arabic groups, Greeks, Romans, Chinese, basically any ancient civilization has somehow connected themselves and their origin stories to the night sky at one point or another. As well, stars are used for navigation when no land can be used as a reference point. So, back before GPS, back before maps, and even if there were maps, they weren't always useful. You're in the middle of the Pacific Ocean on an exploration junket. You cannot see land. How do you know where you are? So easy to get turned around, end up going in the wrong direction. So some of our ancestors were very good at using the stars as a means of navigation. They couldn't pull out their smartphone and follow a map. They would use the stars. They started to notice that there were patterns in these stars, and these patterns we call constellations. And a constellation is a grouping of stars that seem to form some sort of distinct pattern. Sometimes you can see that pattern quite easily, like the Big Dipper. Other times you do have to use your imagination a bit. In the northern hemisphere, we have 88 constellations, and most of these are named after Greek or Arabic mythology. One of the ones that you are likely familiar with is the Big Dipper. So you can see the Big Dipper here is imagining these 7 stars being connected. They seem to form a Big Dipper or ladle. The Big Dipper is also part of the constellation Ursa Major. Ursa Major means the big she bear in the sky, and you can kind of see with the illustration behind how, and using your imagination a little bit, how this group of stars forms a giant bear. Some stars are visible all year, while others are only visible at certain times a year. Uh, in the northern hemisphere, constellations we see all year round tend to be higher in the sky. They tend to be right over top of us. Some of the constellations that are closer to the horizon, these are the ones that are only visible certain times of year. So as Earth is orbiting through space around the sun, our view of these stars, and this, remember, it's the Earth and planets are moving, the stars are all fixed. So as we are moving through space, depending on our tilt, depending on where we are in our orbit, some stars become visible, other stars disappear from our view at different times of years, and then as we get to a different part of our orbit, they reappear again. A star map is a map of the night sky, and it shows the relative position of the stars. And the key here is relative position. So here's an example of a star map, and sometimes some stars look like they are right beside each other, where in reality they're nowhere near each other. When we look up at the sky and we see 2 stars that appear to be beside each other, one might be 50 light years away, another one might be 5,000 light years away, nowhere near each other. One is well behind the other one, but for us, relative to each other, they are right beside each other, and we can plot that in a star map. Star maps are something that we can create because stars don't move, so the stars will be in these relative positions to each other. What we don't have is comet maps or planet maps. These things are constantly moving, and in relation to the stars, they would always be in a different place. But since stars are in a fixed position, we can map them. Imagining where stars are, we use a concept called the celestial sphere. And this is basically a big, huge sphere ball. Imagine a big, huge, clear ball that's out in space and encompasses us. You can kind of see it in the diagram here, the celestial sphere. And what we do is we imagine all the stars at various distances in space. If we were to bring them all in and put them on that celestial sphere, that allows us how we a method to describe the positions of these stars uh, and their movement in the sky. Now, I do want to draw your attention to and their movement in the sky. We know, of course, that stars don't move. However, because the Earth is rotating and revolving around the sun, they appear to move. If you look at the Big Dipper, it's in a different spot in the sky depending on the hour of night. It appears to move, but it doesn't actually move. So the Earth's rotational axis points towards Polaris, which is the North Star. Before the invention of the compass, people used to use this star primarily to tell direction. It told us which way north was. It's a very bright, recognizable star in the sky. We do have stories in our own religion and history of the Magi, the three wise men following the North Star, trying to find baby Jesus at Christmas time. Many cultures also developed calendars based on the sky, while others built structures because of the movement of celestial objects. So I'm thinking Stonehenge, I'm thinking Aztec and Mayan pyramids. You may even have a sundial in your backyard garden. An interesting little tidbit of information. I was at the War Museum in Ottawa over Family Day weekend, and they have a window that sunlight comes through. It's positioned in the building that sunlight only comes through on November 11th at 11 a.m. in the morning. And when that sunlight comes through that window at that one time of year only, it illuminates the headstone of the unknown soldier. So we can see just how predictable the rotations of different celestial objects are, and the apparent movement of these as well. That's it for today. Hope you all have a great day.